So, you've used tools like ChatGPT, right? And you've probably had that moment where you just stop and think, wait, how is this even possible? It honestly feels like magic. Well, today, we're going to pull back the curtain and show you the surprisingly simple secret behind how these incredible language models really work.
I mean, you've probably asked an AI to do all sorts of things, write an email, maybe a poem, or even debug some code. And the way it responds can feel so human, so intelligent. But what if I told you that all of that incredible complexity boils down to one simple, repetitive task? That's the big secret we're going to get into right now.
All right, so the official name for these AIs is a large language model, or you'll see it as LLM. And let's just break that down for a sec. At its core, a language model is a special kind of neural network. That's a computer system kind of modeled on the human brain, and it's been built specifically to understand and work with our language.
So what's its number one job? It's a prediction machine. Seriously, think of it like autocomplete on steroids. If I give it the sentence, the capital of England is, what's the most likely word to come next? London, right? That's it. That is the fundamental task at the heart of everything. Okay, so what about the large part of the name? Well, first off, it refers to the gigantic size of the model itself. This number you're seeing, 175 billion, that's how many parameters are in the GPT-3 model. You can think of parameters as these tiny little adjustable knobs that get tweaked and tuned during training. And every single one of those 175 billion knobs helps the model get just a little bit better at making that one single prediction. What's the next word?
Large also means the absolutely mind-boggling amount of data it's trained on. We are talking about a huge portion of the internet. Think massive web archives, collections with millions of books, and pretty much all of Wikipedia. It learns all the patterns, the context, and the weird little nuances of human language by just digesting trillions of words. Okay, so we know what an LLM is, but how does it process all that data so effectively? I mean, how does it make sense of it all? The answer lies in a really revolutionary piece of technology. So let's head into the engine room and meet the transformer. You know, before transformers came along, older models had to process text sequentially, like reading a sentence one word at a time. This was not only slow, but it had a huge flaw. The model could easily forget what was said at the beginning of a long sentence by the time it got to the end. But transformers? They changed everything by processing all the words in parallel, all at the same time. The magic ingredient here is something called the attention mechanism. Instead of reading word by word, attention lets the model look at the entire sentence at once. For any given word, it can literally weigh the importance of all the other words around it to really understand its true meaning and context. This is how it gets a handle on those complex relationships in our language in the single pass. It's a total game changer. So we have this incredibly powerful transformer architecture. It can see and weigh the importance of every word simultaneously. But what is all this power actually used for? Well, it brings us right back to that simple core mission we talked about. And this quote right here, it really gets to the heart of it. It's so important to understand that the model isn't thinking or understanding the way a person does. It is a statistical powerhouse. It has analyzed so much text that it's just become unbelievably good at calculating the probability of what word should come next, based on all the patterns it's seen before.
So what does that actually look like? Well, imagine you type in, what's your favorite color? The model doesn't have a favorite color. Instead, it just crunches the numbers for every word it knows. It might go, okay, there's a 50% chance the next word is green, a 30% chance for red, and, a tiny 0.1% chance for the word A. Then it just uses those probabilities to make its pick. And it just does this over and over again in a super fast loop. First, it takes your input. Second, it calculates those scores for what could come next. Third, it turns those scores into percentages, into probabilities. Fourth, it picks one and tacks it onto the end of the text. And finally, and this is the really clever bit, that new, slightly longer sentence becomes the brand new input for the very next round. That's how it builds whole paragraphs, one piece at a time. Now, there is one more crucial detail we've got to cover. We've been talking about predicting the next word, but that's not technically correct. The model is actually working with something that's a lot more flexible and efficient. Yup, instead of words, the model operates on things called tokens. A token is the real building block of text for an LLM, and getting your head around this is key to seeing how it can handle the sheer variety of human language. Let's look at this example right here. The phrase, "Good morning, dearest friend," gets broken down into 5 tokens. A common word like morning, that's just one single token. But a less common word like dearest actually gets split into two tokens, D and earest. This system is brilliant because it lets the model handle any word you can throw at it, even brand new ones it's never seen before, by just breaking it down into these smaller, familiar pieces. Okay, let's zoom out and tie this all together. We've seen the massive scale, we've met the powerful transformer engine, and we've uncovered the simple, repetitive task that sits at its very core. It's really the combination of all these pieces that produces such amazing results. So, let's recap the whole thing. LLMs are these gigantic neural networks. They're powered by that amazing transformer architecture. But their one and only job is to predict the next most probable token in a sequence. And here's the kicker. When you perform that one simple task, but you do it billions of times on a model that's been trained on a huge chunk of human knowledge, well, something amazing happens. Complex abilities like writing poetry, summarizing articles, and answering your questions just emerge. And that leaves us with one final fascinating question. If an LLM is just a super sophisticated pattern matching machine, always just predicting the most statistically likely thing, how in the world can it seem so creative? How does it write a beautiful poem or generate a genuinely new idea? That leap from pure statistics to what feels like creativity, that is maybe the most magical and mysterious part of this whole process. Thanks for joining us.